Hi guys, today is a product review day. We got a wonderful power supply, the kind of switching power supply from Owon. They are sponsoring this video and they sponsor the Uni-T. It is the SPE6102. Now let's know about it. The unit came with the manual, the specifications in it, one extra fuse, thanks Owon for it, the unit itself, the power cable, and the USB communication cable. This is what the unit looks like. This, guys, is metal, thick metal, and the front is plastic. So that's great. We're talking about 1.5 kg, about 3 pounds probably, is the weight of this unit. The size is a compact size. It's smaller than many other power supplies I saw in my life, and that's great to put on the shelf. The display has graphics, and that's great. I love it. Also, they have the time running, and that's wonderful when we have to make data logging or batteries charging or to work in function of the time, not only to monitor the voltage but to monitor the time. This is great, guys. If you thought those numbers are big, let me show you this. That's amazing, guys. It's a beautiful view. But let's see what else we have here. We have voltage, and if I punch the button, I can adjust the voltage. I have current. If I punch the button, I can adjust the current. But also in this other side, I have the limits, and that's great, and I really appreciate it, because in my case, 60 volts, 10 amperes is too much power supply for the things I do here. But you know, the fabricant has to make the thing to cover what Bob Kalpon needs and probably what you will need that is not the same than mine. So in my case, I do designs and I keep always the designs under the 34-32 volts DC, and I try to keep it in less than 5 amperes supply, most of the time in 2 amperes. So 10 amperes is too much to make fire on my bench, but I can limit here. I want to work until 34 volts and 5 amperes, and I can set up here what I'm doing now. I will need 5 volts 1 ampere or 5 volts 100 milliamperes as example, and this is great function for designers. We have memory, and I can set up the voltage I need, the current I'm expecting to consume, but in the same way I can set up the voltage limit and the current limit, the total. So from this I can withdraw whatever I want in this other side. That's great. With a 5 volts 1 ampere USB power supply, I also have one button. When I do the settings, I am not getting the voltage in the output until I punch the button. Probably I think on off is a mistake. Probably what I need to write there is output. One of the downsides in this power supply, because you know guys, when I make product reviews, I put the product against the specifications. I have not opinion, but it's important to speak and to show everything. If the product accomplished with the specifications, the product is what it says it was. But let's see the downsides too. As I said, this button is for the output. So when I punch it, there is no voltage now, and now there is voltage. Here is the monitor point for that. So this is the output to connect the voltage we set up on the screen with the boards. The power button for this unit is behind the unit, is in the rear side, and that's one of the downsides of it. Why? Because if I'm going to put it on the shelf on the side, maybe I can squeeze the hand and to punch the button. Otherwise I cannot turn it off. If I'm going to put it in a stand like the one I have here, then it's a problem. I have one solution for this kind of situations, and is I use an outlet with switches, and it stops being my problem any longer. I control the power supply from there, and I also control all the electronics equipment that is connected in passive consume. I shut it down on the nights, and I don't pay for the passive consume, or if I'm not going to be here for 3 days, it has no sense to warm it inside. So for you to know it, this is the situation with that. Let's say I want to use the memory one. So what I have to do is just to move the rotative knob until I get in the line I want, and just hold the button there. Now I have 10 volts, 5 amperes, and I am ready to turn on. Or if I want to set up myself, voltage, I mean the second digit, 5 volts, amperes, $1 ampere, and the overprotection I want 32 volts, and I want 5 amperes maximum over current protection. Keep moving the cursor. And that's it. Easy to use. Now let's talk about the voltage. The reading says 4.97. The digital multimeter 4.98. The 3-in-1 oscilloscope multimeter and function generator from Owon says 4.98. The same. And this little difference, the truth is okay, is perfect. The difference is not too much and is in the correct range of reading. But just to explain a little bit, when do I get this a little different, is because the analog to digital conversion is by steps, and it depends the amount of bits I have in the converter is the difference between one step to the other. Anyhow, the unit shows a good value. And just to understand a little bit, when I set up 5 volts, this unit probably will give me the 4.99 something, and in the specifications I can drop until 20 millivolts or even 30 millivolts according to the specifications. According to the specifications, there is a variation voltage I can get That means the minimum acceptable voltage is 187 volts. The maximum acceptable voltage is 153. That's under the network voltage and upper the network voltage. So whatever variation in that range happens, the voltage I have set should be the same voltage in the output. Here I have a variac to make that variation. Here I have a current meter, that's the network voltage, the AC line, let's say the primary. And this is the 187 voltage from the variac, that is what I'm feeding right now, the unit. And this is the output voltage. From 187 to 253. Pay attention there. $253 volts there, and the voltage keep the same. The power supply is according to the specifications. Something else. It says for no load, the consume should be less than 150 milliamperes. And yes, we have less than 150 milliamperes. That's right. I cannot make the full load consume because I don't have anything to drink 200 watts from this power supply. So when I tell you guys I work with low power and I have things that are enough in my workshop for what I'm doing, that's what I mean. I try even the hot air pistol. This 1500 watts in AC, and I only could drink from that 1 ampere. So I don't have anything to make a load to this unit and to take the 200 watts. That test will be later in the future if we can make it. What is equal voltage times current, and 60 volts times 10 amperes is 600 watts, not 200. That means whatever voltage I use or whatever current I use, whichever one reaches the 200 watts, this is the power that the unit will use, and I'm limited to some kind of voltage and some kind of currents on it. There are other models in Owon that you can choose too, but it's necessary for you to understand what I said and probably to make the table to do not fall same than other YouTubers that couldn't catch that idea. According to the specifications, ripple and noise bandwidth with 20 MHz, ripple bandwidth with 1 MHz, we need to connect 10 microfarads electrolytic capacitor in parallel with 0.1 microfarads ceramic capacitor to the output terminal of the testing. And let's see what can we get here, because it says the voltage peak to peak should be less than 50 millivolts and the voltage RMS should be less than 5 millivolts for my model SPE6102. This is the power supply with the differential probe, and in the oscilloscope the ripple is more than the 50 millivolts. If you can see the two lines in parallel, and the RMS is more than 5 millivolts and the ripple is more than that. I'm using the AC coupling 20 megahertz bandwidth, and the scale is in the 1 microsecond. So yes, it didn't pass. I'm going to use the acquisition in average, and maybe with the acquisition in average, okay, we can say the noise is under the 50 millivolts, the RMS is supposedly equal or less than 5, let's say it's okay there, and the peak to peak is still higher than the 50 millivolts in the ripple. So let's say yes and no, and is it expectable in any switching power supply? That's what happens. Owon didn't tell us in which voltage was it made, with load, without load, and now I'm going to pass this filter directly to the test point, the measurement point, not in the output of the power supply. Now, without the electronics load, and the capacitor in the measurement point, yes, it passed the specification as is written. Thanks, Owon, for the unit. I like it. I'm going to use it, and we are going to learn from it. Ripple, yes, guys, it's a switching power supply, and it's not the same the ripple from the linear than the switching, and we have to always deal with commutated power supplies. So let's learn from this point to ahead how to deal with the switching mode power supplies. Thanks, guys, by watching the video. Thanks, Owon, by the unit. I like it a lot. We are going to use it, and we are going to learn a lot from this unit too.